All right, this is the first chapter calculus accelerated. So first thing we got to talk about is straight lines. We have three equations for straight lines. You have slope-intercept form, y equals mx plus b. The reason we call it slope-intercept form because we have a slope and we have an intercept. We have point slope form, which is y minus y1 equals m x minus x1. We call it point intercept form because we have a slope. Oh, I'm sorry, we call this point slope form because we have a slope and we have a specific point. And then there's standard form. Standard form is ax plus by equals c. This standard form doesn't really make sense too much in a linear sense, but it does make sense when you talk about different other equations combined with it. So it's important to know for that reason. So the questions I could ask this is, I could ask you, give me a line that passes through 3, 2, and 5, 7, something like that. So first thing we have to do is find the slope, which is y, or let me put the formula, y2 minus y1 over x2 minus x1. So in this case, 7 minus 2 over 5 minus 3, which is going to be 5 over 2, or 2.5, doesn't matter how you write it. So that's your slope. So now we need to find the b. If I find the b, so y equals, or actually have a specific y. So I'll use this point. Remember, it doesn't matter which point you use. So 2 equals 2.5 times 3. You could leave it as a fraction if you really want to, plus b. And maybe it's better to leave it as a fraction, honestly. So 2 equals 2.5 times 3 is 7.5 plus b. Minus 7.5 on both sides. Negative 5.5 equals b. Yes. So negative 5.5 equals b. I'm recording. So y equals 2.5 x minus 5.5, or the same thing, y equals 5 halves x minus 11 halves. Okay, both are good. Now, this is in slope-intercept form. I might ask you to do it in point slope form. That's a little easier because as soon as you found the slope, you just pick one of these points and plug it into this equation. So point slope form would just look like this. Look like this. Y minus 2 equals 5 over 2 x minus 3. So even easier than slope-intercept form because you don't have this boundary.
You just do it like that.
Yeah, you just leave it like that. Now, if I ask you to do it, that was point slope form. If I ask you to do it in standard form, to do it in standard form, what you have to do is put it in point slope form. In this case, we already did that. And then convert it to standard form, which is having x and y on one side and a singular number on the other side. So I'm going to take this 5, 2 and distribute it. So y minus 2 equals 5 over 2 x minus, we'll do 15 over 2. Okay. Then we're going to move all the x's to one side. We're going to move all the y's to the other side. So negative 5 over 2 x plus y equals plus 2 on both sides. So that's 4 over 2, so negative 11 over 2. Okay. The only difference about standard form is that it should be whole numbers. So in order to make this the thing whole number, what would we do to both sides? Multiply by what? Good, multiply by 2. So it should be negative 5x plus 2y equals negative 11. I don't know if there's a rule about which one should be negative or positive, so I'm just going to leave it like this. Okay? But there might be a rule that this is positive, negative. I'll let you know tomorrow, okay? All right. Okay. So let's continue. All right. Let's identify some domains and ranges. Let's identify some domain and ranges. So let's just talk about all our parent functions. We have y equals x. Remember that it's just a straight diagonal line. The domain and range is all reals. To save time, I'm just going to type all reals. But remember how we write all reals is actually negative infinity to infinity, okay? All right. So you have y equals x squared. In this case, it looks like this, a parabola, where the domain is all reals, but the range is from, it hits 0, and it goes up to positive infinity. You have x cubed, which looks like this weird-ass thing. All reals again. Okay, you have square root of x. Looks like this. It starts at 0, and then it goes like that. In that case, that is a good. So the domain is going to be from a hard 0 to infinity, and then range is also a hard 0 to infinity. Good. Because you can't plug in negative numbers, and you won't get back negative numbers. Okay. It's actually the same curve as this thing, the parabola, just turned to the side. Okay. At least half of the curve, I should say. Absolute value, similar to parabola. So absolute value is the V shape, but it's the same exact thing as domain and range of the absolute value or of parabolas. Negative or 0, hard bracket is 0 to infinity. Soft bracket. We have exponentials. So let's say a to the x. This is the same thing as e to the x, okay? So exponentials, you have a curve that goes along 0 and then shoots straight up. In that case, the domain is all reals, while the range in this case is going to be from a soft bracket 0 to infinity. Okay? Remember, vertical shifts shift the range, horizontal shifts shift the domain. But if your domain is all reals, it doesn't shift. Yes.
But why are you like plugging negative?
Negative? You can have a negative exponent because remember, like 3 to the negative 2 is just 3 squared. Yeah. So that's okay. That doesn't cause a problem. The only issue, a can't be a negative. So you can't have like negative 2 to the second power because that's okay. But as soon as you have like negative 2 to the half power, aka square root of negative 2, that can't exist. So you can't have negatives in the a value, but you can have negatives in the exponents. So if I ask you something like, give me the domain and range of something like the absolute value minus 2 plus 4. Let's say something like this. In this scenario, it has a horizontal shift of 2, so right 2, and then a vertical shift of 4, so up 4. 4. It's right 2? Yeah, it's right 2. Now, if I just talk about the domain and range, the domain is still infinity to infinity, so nothing has changed. But the range in this case, it went up 4. So now I'm going to have a hard bracket starting at what number?
4.
4, good, because I start at 4. So 4 comma infinity. Or I should say the normal one starts at 0. You're just moving up 4. So you're physically moving it up 4. And then if I did ask you to sketch a graph of it,
The right 2 isn't affected?
it'll affect the graph, but it does not affect the domain and range. So if I asked you to sketch a graph of it, you would go right 2 and up 4, start off, and then just make your V shape. You will have calculators on this test. So worst case scenario, you could just plug it into your calculator to see the graph, okay? Right. And then I could just give you a bunch of transformation ones. You want to keep practicing transformations or you want to move on? Sure. Let's do e to the x plus 1 plus 3. So this is an exponential function. Mm-hmm. Up 3, good.
domain is all real,
Yeah.
and the range is 3, hard bracket 3, common 3.
Soft bracket 3. It never reaches 0 in the same way it'll never reach 3. Because it'll get a small, small, small fraction the more negative you get, but you can never make a fraction into 0. So soft bracket 3 to infinity. And again, you have your calculator, so you can literally just open your calculator and pull up table and just put up the points. But the key part is usually it's at 0, 1. So we're actually moving left 1 and then up 3. So you know one of the things it's going to hit is the -1, 4. What's it? Yeah, the standard exponential graph starts at 0, 1. Because if you plug in a 0, no matter what the base is, it'll become 1. So here, if I plug in a -1, that makes this 0. And it's usually already 1 up. So it's 1 plus 3 or 4. E to the -1 plus 1 plus 3. This is e to the 0. Well, what's e to the 0? 1 plus 3 is? 4, yeah. So it's going to be -1, 4. So you always base it off 0, 1. And again, type in your calculator, get a guaranteed. And then let's do one that has both domain and range different. So that's what, like the square root.
Oh, do you have to do
The asymptote? Let me just mention the asymptote. Yeah.
You should put it right under.
Yeah, you put it under, and the asymptote is y equals 3, aka your domain. Let's do one more. Square root, which has something on both. X plus 2 minus 4. Let's put 2 here also in front, just to talk about it. Okay, so what's happening transformation-wise?
The vertical stretch 2.
Good.
Left 2.
Mm-hmm.
And down 4.
Good, down 4. So for this graph, we're going to go left 2, down 4.
Domain is is it plus 2? Does that change it? You can't be.
The domain will be changed, actually.
So it's -1 to infinity?
Not -1, -2 to infinity.
-2 software.
No, hard bracket, because you could have a 0 in there. Plugging in a 0 will be okay. So -2 to infinity. And then range is going to be 4 down. So that's going to be -4, hard bracket, to infinity. And then your curve is a little swoop like that. A little bit taller than normal just because it's a vertical stretch of 2. Again, I'm not going to grade you too hard on like if it's tall enough or short enough or whatever. Okay. All right, let's talk about even and odds. Even functions, kind of like a parabola, is that when I plug in something, I should get back let me say that like this. When I plug in a positive number, I should get the same answer as when I plug in the negative version of that number, okay? So to test if something is even, and then odd, I should say that first. Odd is that when I plug in the negative of that number, I should get the negative version of it if I plugged in a positive number. And we'll do x cubed, for example. Quick example of what that means. So like 2 squared is 4. I plugged in a positive number. I got 4. -2 squared is also 4. So plugging in the negative number still gave me the same answer. While odd is saying, let's say 2 cubed is 8. When I plug in a negative version of 2, it should be a negative version of the answer, no -8. Yeah, okay? So that's what it's saying. So to test it, what you could do is you plug in a number or you plug in positive and negative x. So if I want to test something like negative x cubed plus x minus 1. Okay. So what I could do is, first off, this is f of x, aka this is the result that will happen if I plug in a positive number. So if I plug in a negative number, if I end up getting the same answer, aka this looks the same, then it must have been even. If I get a negative flip of this answer, like a perfect negative flip, not just some of it, but all of it, then it must be an odd. And then there's an option of neither. It could be neither even or odd. In this case, if I plug in a negative x, so negative x to the third plus negative x minus 1. Negative x cubed is still negative, correct? So negative, that's going to be a positive x cubed minus x minus 1. So in this scenario, here and here is a negative flip, which is good. Here and here is a negative flip, which is good. But this is not a negative flip. So in this case, it'll be neither. Okay? If it was just this version, where let's say it wasn't the plus or minus 1, and this is f of x. When I plug in a negative x, I would end up getting what I got here, x cubed minus x. In this scenario, it's a negative flip. And in that case, this would be odd. Okay? So you've seen the difference between odd and neither? And then for an even scenario, let's say f of x is...
You only check if it's like x cubed, you only check if it's odd. If it's x squared, you only check if it's even.
Yeah. Or it should be odd power, I should say.
Yeah.
Odd power, yeah. So x squared plus 2, let's say something like that. If I plug in a negative x, I'll get negative x squared plus 2. But wait a second, what's negative x squared? X squared. So in this scenario, I got exactly the same answer as my original. So that must mean it's even. Okay. And remember, if you see a power to the 3, you automatically know it can't be even. If you see a power of 2, you automatically know it can't be odd. So realistically, only test what you need to test, but yeah. Okay, next one. Let this load up.
It's really changing the y and the x, right? Flipping that.
Inverse? Yeah, there's going to be inverse. So let me just see. Before we talk about inverse, let's talk about I forgot what it's called. Combination functions? I forgot what it's called. But a function and a function. All right. So let's say if I gave you f of x equals x cubed minus 2, and I gave you g of x equals x plus 1. Or let's do x minus 1. Okay. So I'll ask you either find f of g of x. I could ask you to reverse g of f of x. Or I might ask you for a specific number, which is f, let's say, of g of 2. Okay? So let me tell you both. F of g of x, I'm going to replace the g of x, which is the exact equation that it is. So f of x minus 1 minus 2. Okay? Or I'm sorry, not minus 2 does not show up. It's just f x minus 1. But then I'm going to take this x minus 1 and plug it into every x I see. So x minus 1 cubed minus 2. Now, I didn't realize this is going to be a problem, but this will not show up this level of the test. But technically, you're supposed to write x minus 1, x minus 1, x minus 1, and then like do the foiling of that. Oh, yeah. Let's pretend we did that. It's going to be x cubed minus 2x squared plus x squared, or x to the 1 power minus 1. So that's if you did all the work. That's the quick answer of it, 2x minus 1. I won't give you something that forces you to FOIL 3 times like that. And then that minus 2 from originally. So just remember you got to combine any like terms. So your final answer is negative 3 at the end. Okay. Now, if I ask you for f of g of 2, there's 2 ways to go about it. You could just solve g of 2 first. This is the way I recommend. Solve g of 2 first, which is
1.
Good. 2 minus 1, which means that's 1. Then you take that f of 1 and now plug it into x.
Yes.
1 minus 1 cubed minus 2. 1 minus 2. Negative 1 is your final answer. Okay? Another way you could do it is if you found already f of g of x, you could just plug it into your final answer over here. Risky part about that is if you made a mistake here, it will cause you to be a mistake here. So I imagine doing piecewise is the best move. This, if I did it correctly, should be the same.
And is it f of 1?
So 8 minus 8 plus 4 minus 3. Oh, I get positive. So I messed up something with the multiplication here. But yeah. What's up?
Is it so like is f1 f of 1 equals negative 1? Like that's like you write f of 1.
So you write, well, I guess f of g of 2 is negative 1. This is negative 1 as a whole. F of 1 is 1 cubed minus 2, which eventually you get to negative 1. Okay? All right. Don't bother me right now. If you have to rewrite an exponent base, so let's do 9 2x equals 1/3 x plus 1. Yeah, that's fine. You make the bases the same. The best thing to do is make them both 3, okay? So to make a 9 a 3, good, because 9 is 3 squared. So I'm going to rewrite this as 3 squared times 2x. While here, 1/3, excellent, 3 to the negative 1 power. So it's going to be 3 to the negative 1 to the x plus 1. Once that, you could just distribute. And then cross those out and solve. 4x negative 1/5. You got plus 1 on both sides. You got to distribute a negative to both. Because you got a plus x on both sides. So it's 5x equals negative 1.
Oh, yeah, you're right.
So negative 1/5. Yeah, exactly. So just rewrite the base. Is remember you just set it equal to it and then rewrite it and make sure you multiply the things. Okay. Inverse. It is a stack test because it's basically all of last year in one chapter. Negative 5x cubed minus 2. Let's say do that. Okay. All right. When making the inverse, you make the fx into a y. Then you just swap the x and y physically. So every x becomes a y, every y becomes an x. Then you solve for y's, which means get y by itself. So I would do plus 2 first. Divided by 5, negative 5. X plus 2 divided by negative 5 equals y cubed. And to get rid of a cube, you got a cube root. So your final answer is the cube root of x plus 2 over negative 5. You can rewrite the negative however you want, equals y. You can put the negative on the outside, it doesn't really matter. And if I want to check if something is inverse of each other, what I can do, if I ask you, like I might give you two functions, like f of x and g of x, and I say, please prove these are inverses. So I'll use this one because I already know it's inverse. Not g equals x, g of x. So in this case, what you do is you plug them into each other. So in this scenario, if you take f of g of x and g of f of x, they should both result into just x, aka everything gets canceled out. I'm going to do it for one of them, and then you'll understand the other one. So what was my original? So negative 5x cubed minus 2. So I'm going to plug in g of x into here. So negative 5, the cube root of x plus 2 divided by 5, negative 5, cubed minus 2. Well, cube and the cube root cancels out. So I have negative 5 times x plus 2 over negative 5 minus 2. Negative 5s cancel out. X plus 2 minus 2. Minus 2 plus 2 cancel out, which is just x, okay? On the test, you have to do both sides, okay? All right.
So
I'm plugging in the f of x into the g of x. So the setup would be cube root of negative 5 x cubed minus 2 plus 2 over negative 5, which eventually will cancel out to x, okay? I don't want to run out of time because it is a lot of stuff. Using logs to solve, just remember, like if you have not b, let's say like 3, 2x plus 1 equals 10. In this scenario, you can't just make them the same base. 10 cannot be a base of 3. The previous one it could, but this one no. So what we're going to do is take this 3 and move it to the other side. The only way we could do that is with a log. So this is going to be 2x plus 1 equals log with a base 3, a normal size 10. I'll put parentheses to indicate that's inside. Minus 1 on both sides. 2x equals log base 3, 10 minus 1, then divided by 2 on both sides. So your answer would be this thing. But let me just show you how to put it into the calculator. But just remember, if you have, let's say, a log with a different base than 10 or e, aka ln, you can always rewrite it as log 10 over log 3. And then just so you got the calculator answer real quick, it's going to be log 10 divided by, this is really small for you guys, divided by log 3, that'd be some crazy decimal, minus 1. I would do that first, just because you're going to deal with the decimal better. So I do then minus 1, then divided by 2. I do it piecewise. You could technically type it all at once, but that causes errors because if you type it wrong in any way, like if you didn't put everything in parentheses, like it will cause a problem. Right. So the answer is like 0.55. All right. So that's a exponential question. You could also do a log question where I have log base 2 5x equals log base 2 3x minus 1. In this scenario, well, this scenario is fine because they have the same logs. You can just cross them out. 5x equals 3x minus 1. A little bit of algebra. X equals a negative half. Okay. But in the scenario when they're not the same, log base 2 5x equals 10. Or I'll use 8. In this scenario, when you move over the 2, you have to bring it to the other side. Remember, it's going to become an exponent. So 5x goes 2 to the 8th power, divided by 5, divided by 5. 2 to the 8th power divided by 5. 2 to the 8th power is what? 16 times 16, 196 over 5. Yeah. Last thing is the word problems, like the half-life and interest ones. Remember, if I say something like the half-life of a amoeba or something like that, that means the formula is going to be your final amount equals your... I forgot how we did it, actually. I forgot, what was the letters we used, so I could just be consistent. Because I know final amount is for the money one. No, that's for the money. There's another one before that, half-life. It had like half as the exponent. If not, let's just go through it. The final amount is equal the starting amount. I'll call it S for now. I use different numbers in the notes. I just don't remember what it was, or different letters, I say. To the half power, to the half base, I should say, to the power of time. Okay. So if I said for 3 years, time divided by by hours or something like that, or days. I forgot what I call it. I don't know what I call it. N. Yeah, N of number of times per year. What was the previous one though? I had notes. Give me a sec. I'll open the notes. Let me just use I want to use the same verbiage, so it's the same for both classes.
Is there piecewise? Or are you gonna?
No graphing piecewise, so don't sweat it. At least the test I got did not piece. There's something I would include, but it wasn't included. So, Oh, I didn't give you letters for it. That's why. My fault. Okay, so it's let me rewrite it so it's clear. It's going to be your answer is equal your starting amount. I don't know. I'll call S times a half power to what you're looking for over how long it takes. So the example we did in the notes was, I shouldn't use S, but it was 5 Gs initially. So how long will it take to be 1 G left over? So it'll be X over 20. And because it takes 20 days to lose half of it each time. Yeah, R, there we go. So it's like that, okay? And then we know we're aiming for 1. So in this scenario, I would divide by 5, so 1/5 equals 1/2 X over 20. I got to get rid of this base of an exponent, so I got to move it over here. So it's log to the half power, 1 over 5, X over 20. You got to type that in your calculator, then multiply by 20, okay? So this is a half-life, half in the middle. Doubles, it's just a 2 in the middle, same thing. And then we had the money ones, which we talked about in detail in the past, which is A equals P, 1 plus R over N, T. Remember, N is how many times per year. And then if it's continuous, if you see the word continuous, much easier, P to the E power, or E base, RT. No N needed, okay? So those are hopefully that covers everything we got.